So in this section, we'll be discussing the calculation of the post-mortem time interval through all the studies of entomologies that we have known, to all the core knowledge that we have to the beetles. What are the type of beetles basically that start feeding on when we have a fresher carcass? When there is a fresher carcass, we'll have the blue bottles, the green bottles, and the blowflies. And when we have a decomposed carcass, mostly there'll be the house flies and the flesh flies. So this is basically a core knowledge. Then we had another core knowledge that we had. That the blue bottles or the blowflies, they prefer to lay their eggs in the daytime. That means that if we find a dead body with the pupas or the eggs of the blowflies, it means that the minimum time interval that has passed on is 24 hours because we found the dead body at the night time. So in this section, we'll be discussing the temperature effects on the insect growth. How does basically the life cycle, as I've already discussed in detail in the previous sections, there is an egg, then there is the pupal and the larval stages, and then there is an adult stage. So all of these stages, how are they affected by the temperatures, the insect development, how does it take place, and the degree day accumulation method by which we can calculate the post-mortem time intervals. So that will be discussed in detail in this section. Now, the post-mortem time interval is basically defined as the elapsed time from a death to the discovery of a cadaver. So that is basically the post-mortem time interval, and we are trying to calculate that time interval through different methods. The flies are vital in determining the PMIs. One of the methods for determining the post-mortem time interval is the flies, the collection of all of these samples that we take from a cadaver, and we basically experiment on them to basically calculate what are the type of flies which were found on the dead body and in which stages were they. They begin ovipositions as soon as we discover a dead body. Now, the fly developmental stages, they are structured into stages. Here we can see we have a male and a female fly. Moving on, we can move on to the embryo stage, the first larval stage, and then comes the second larval stage. And finally, we have the third larval stage. As it basically grows in size and in its physique, it's basically moving on to the subsequent stages. Then we have the pupal stage, and then we have the prepupal and the pupal stage finally. And all of these stages basically contribute to estimating the time since death. Each stage requires a certain amount of time, and it depends upon the type of the species of the insect that we are dealing with. An entomologist who is investigating any crime scene should have a core knowledge as to how much time it takes from a larva to become to a pupa in a particular species, and from a pupal stage to become an adult in a particular species, because these things are very important when we are calculating the time since death. The time to complete the stages depend on the temperature. So we have to keep in our mind whenever we are dealing with a particular case, it doesn't have very strict rules. It depends upon the type of the climatic conditions in which the dead body was placed, and the positioning of the dead body, and the type of the geographical insects that are found in that place. They're very important. They're mainstay to the calculations of all of these calculations. Now, the faster development at a warmer temperature. The main rule that basically applies to most of the insects is there is a faster development at a higher temperature. So as we move to the tropical areas, all of these stages will be completed in a quicker manner. All of these environmental conditions, the humidity also basically prefers, because some of the insects, as I've already discussed in the previous section, the flesh flies, the blue bottles, the green bottles, they try to have a humid and basically a moist environment when they're laying their eggs. For example, they try to prefer to lay their eggs in the oral cavity, in the nasal mucosa, the vagina, and the anal regions are basically involved while they're laying their eggs. So all of these factors, they come into play while a life cycle of any insect has been completed. Moving on to the temperature effects on the insect growth. How do we measure an insect growth? What are the factors that are involved? Now, this is basically a sigmoidal shaped curve. There is a lower threshold of the temperatures in this curve, you can see, and then there is an upper threshold for the temperatures. There's a particular developmental rate at which all these insects pass on to their different stages, from the egg stage to the pupal stage to the larval stage to the adult stage. They need a particular type of environment, a particular type of temperature. There is a lower threshold to the temperature as well as an upper threshold to the temperature to develop through all of these stages. And apart from the temperature, there are other factors, for example, humidity, the air, the sunlight. All of these factors also come into play whenever we are discussing the insect growth. Now, the insect development, the temperature and time is the mainstay whenever we are discussing the insect development. On this graph, as you can see, we are dealing with a temperature on the y-axis, and we are dealing with the time on the x-axis. And as basically there are two curves to all of these. As the temperature increases, the time also increases. There's an upper threshold to the temperatures as well as the lower threshold. The yellow parts basically designate the ideal developmental phases of the insect development, and there is a minimum and a maximum threshold that has to be maintained when an insect develops through its stages. So all of these factors come into play while we are discussing the insect development. Then there is this degree day accumulation phase, and basically this is a formula to calculate the degree day accumulation for a species with a 10 centigrades threshold. So basically there is a daily max, and we basically subtract it, the 10 which is a constant is subtracted from the daily max development, and then we have a daily minimum development, and the 10 threshold is basically subtracted from it. All of this maximum and the minimums are added upon, and then they're divided by 2. If the maximum or minimum development is less than 10, then you can enter 0 in this formula. So this is basically a simplified formula for the degree day accumulation of any insect or the predators or the larvae which are feeding on the dead carcasses. This table basically simplifies us the maximums and the minimums at the basis of the data which are calculated when we take 10 as a constant. And all of these degree day accumulations can be calculated through this method. So in this section, basically, we dealt with the developmental phases of the larval and the pupal stages of different insects, and what are the factors basically which influence the insect development, which are very important when we are calculating the post-mortem time intervals. Thank you for watching sqadia.com.